Welcome to Lecture Online. While I was doing the last example, our example number 2 of RC circuits, I thought of something. There's another way in which we can find the current across a capacitor once we find the voltage across a capacitor. If you look at our previous video or previous example, you can see that the voltage across a capacitor was defined as being the initial voltage of 10 volts times e to the minus t over tau, and tau was 36 seconds, which was the equivalent resistance of the circuit times the capacitance. But once you have the voltage across the capacitor, you can find the current by using the definition of the current through a capacitor. The definition of the current through a capacitor is equal to the capacitance times the change in the voltage divided by time. And since we have the voltage here in this equation, we can simply take the time derivative of that voltage to find the current. So here we can say that I, the current through the capacitor, which is a function of time, is equal to the capacitance, which is 1 farad, times the derivative with respect to time of the voltage. And the voltage is right here, it's 10 volts, times e to the minus t over 36 seconds. When we take the derivative of an exponential function like that, what we get is that this is equal to 1 farad. So this is 1 farad times 10 volts times the derivative of that, which is e to the minus t over 36 seconds. You simply get the same function back, times the derivative of the exponent, which would be a minus 1 over 36. So times a minus 1 over 36 seconds. And so that means that this is equal to, calculator, you have 10 divided by 36, and that would be the same answer as we got before. It would be 0.28 amps. Now, of course, we do have that negative sign there, so we'll put the negative sign in front. There we go. Times e to the minus t over 36 seconds. The only difference between our answer here and the answer that we got in the previous video is the negative sign, but again, that's not relevant in this case. The reason why it's not relevant is because we do not know in which direction the current was going to flow. In the first place, we had no indication in which direction the initial current will flow, and therefore, positive or negative doesn't make any difference. But the answer is exactly the same as we got in the previous video by taking the definition of the current through a capacitor. And that's how it's done.